Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will look at traversal of binary tree. First we need to understand what do you mean by traversal. Traversal is visiting from root to the node. This is called as traversal. There are three types of traversal: in-order traversal, pre-order traversal, post-order traversal. Let us begin with the topic. First we will go for in-order traversal. In case of in-order traversal, we are going to find out the from root to the node. That is, we are going to visit the root then node. Like this we are going to traverse. So let us begin. Public void in order. This is the function I have defined. Inside that I have defined another function which I am going to call it recursively. That is in order root. So the parameter passed is the root. That is your root node. For this we are going to define a variable r. Then I have defined a function called as private void in order, in which I have passed the parameter bt node, which is the class. Its reference variable as r. R will stand for root. Then we will check with the condition. Let us begin with the checking with the condition. First condition, if root not equal to null. What does it means is that there is some node present in the tree. Hence we write down if root not equal to null. If root is not equal to null, that means there is some node present. Let us begin with that traversal. In that case, we are going to call the recursively function in order r dot get left. So you need to remember that in order we are going to call it, and it is going to be in order r dot get left. That is, we are going to move to the left hand side first. We are going to print that data first. Hence the name in order r dot get left. Then after this, once we have finished with the left hand side, okay, so we have done with the left. Then we will move to the data part. Hence I write down system dot out dot print r dot get data. That is, we are going to print the data of root node. Once we are done with that one, then we are again going to call recursively function called as in order. In that we are going to pass in order r dot get right. That is, we are going to print the data of right node. So let us summarize the in order. In case of in order, we are going to check if root is not equal to null. Once that is done, then we move to the left node. Once that is done, we move to the root node. Once that is done, we move to the right node. That is how we are going to traverse in case of in order. Now we will look at pre-order. In case of pre-order, we are going to print the data first, left, then right. Let's look at it. Public void pre-order. Then we are going to call recursively the function pre-order through the parameter root. Then we are going to call the function private void pre-order, in which we are going to pass the parameter that is the reference of class bt node. We are going to take the variable r. R would stand for the root node, hence r name. Once we are done with this one, we are going to call the conditions. First condition is the common condition for all the things. That is all the traversal. That is, we are going to check whether there is node present or not. For this I have written if r not equal to null. When this is done, that is, there is some node present in the given tree. In that case, we will move to the pre-order in this case. Hence we write down system.print r dot get data. That is, we are going to print the data of root node first, then we will move to the another node. That is, we are going to move to the child nodes after we print the root node. Hence we write down system.print r dot get data. We print the data of root node. Once this is done, then we are going to write down pre-order r dot get left. That is, we are going to move to the left child of the node. Once we are done with the left, remaining will be, yes, you have guessed it right, we are going to move to the right hand side. So let us summarize the pre-order. In case of pre-order, we go to the root node first, we print its data, then we move to the left hand child, and after left hand child we move to the right hand child. This is how we are going to perform the pre-order traversal. Once we are done with the in order and pre-order, the last one remaining will be post order. The last one remaining will be post order. In case of post order, we are going to move to the left hand side, right hand side, and then the data. Let's begin with the post order. I have defined a function called as public void post order. Inside that I am going to recursively call post order root. Hence I write down private void post order, in which I am going to pass the parameter bt node r. R will be for root node, and bt node is the class which we have defined, and r is to be taken as a root node reference variable. First condition is common for every traversal method. That is, there are three traversal methods. We are going to write down the function, and then inside that we are going to check the condition. If r not equal to null, so it means that there is some node present in the given tree. Let us begin. If r not equal to null, then we are going to recursively call post order r dot get left. So we move to the left hand child. Once we are done with the left, then we move to the right hand child. Once we are done with the right hand child, then only we will move to the last part, that is system.out.print r.getData. That is your root node. So let us summarize the post order. In case of post order, we move to the left. After that, we move to the right. Once that is done, then we move to the root node. This is how the post order traversal is done. Now let us begin with the main function. I defined a class called as binary tree. Inside main, I have taken the variable called as scan. Now this is not the exact variable. We are going to saying it as, we are going to create the object of the scanner class. You must remember, we are going to create the object of the scanner class so that we can take the value from the user. Hence I write down scanner scan equal to new scanner system.in. Then we are going to create the object of bt class. How do we create the object of bt class? We write down bt equal to new bt. That is how we create the object of bt class. Then we will move to the performing various tree operations. That is, we are going to write down system.out.println binary tree test. Then we have defined a variable called as ch of type char. You must remember, char is for taking the user value whether he wants to continue with the operations or not. That is for yes, y, and for no, n. This is how you are going to continue the operation or discontinue the set of operation. Once we are done with this one, we are going to perform the menu driven approach. Now we are going to give the menu driven approach to the user. That is, we are going to give him the list of operations which he can perform. For this I have written do while loop. System.out.print binary tree operations, which are this one. First is insert, second is search, third is count nodes, and fourth is check empty. Once this is done, we are going to take the value from the user and store it in a variable called as choice. Hence I write down int choice equal to scan dot next int. Once this is done, then we are going to move to the switch case. Let us begin with the switch case. Case number 1, we are going to take the integer element to be inserted. Hence I write down system.out.println enter integer element to insert. Once this is done, we are going to call the object of bt class. Hence we are going to write bt. Then after that, we are going to call the function called as insert. We write down bt.insert scan.next int. So the user enters the value and we are going to insert into the particular tree. That is your binary tree. Once this is done, case number 1 is done, then we have moved to the case number 2, which is your search case. Case number 2, we write down enter integer element to search. Once this is taken from the user, we are going to write down search result bt.search scan.next int. That is, we are going to call the function called as search, which I have already predefined before this lecture, in which we have written clearly how to search the value in a particular given tree. Hence we write down bt.search. Once we are done with the case number 2, then we move to the case number 3, that is your nodes. That is, you are going to count the number of nodes in the given binary tree. Now the number of nodes may increase or decrease depending how you are going to insert or delete the node from the given tree. So in case number 3, we are going to write down nodes equal to bt.count nodes is the function which you are going to give the value of number of nodes in the given binary tree. Once we are done with the case number 3, then we move to case number 4, which is what we are going to check whether the tree is empty or not. That is, the status is what? Is it empty or not? We have already defined a function called as isEmpty. Hence we write down empty status equal to bt.isEmpty. This is going to give me the value whether the nodes are present in the given binary tree or not. Once we are done with all these 4 cases, there may be a case where user enters value greater than 4, or we can say less than 1. That is your default case. For this, you are going to write down default system.out.println wrong entry. That is, you are going to define the user that this set of values which is going to give is not given for the given list of operations. Hence it becomes a default value. Once we are given the choice which the user wants to perform for the list of operations, then we will start performing the binary traversal. For this, we are going to write down which set of traversal the user wants to go through. Hence, we write down system.println post order. For post order, we are going to call the object of the BT class. Hence, we write down BT.post order. Then we call for the pre-order. So, for pre-order, we write down BT.pre-order. Then last will be in order. For in order, we are going to write BT.in order. So basically there are three techniques for traversal: pre-order, post-order and in order. So based on which function you are going to call, that particular set of traversal will be called up. Once we are done with this one, then we are going to ask the user whether he wants to continue with the set of operations or not. For this, he has to enter Y or N. If he enters Y, it means yes, and if he enters N, it means no. So based on this set of operations, we are going to see whether we want to continue with the set of operations or not.
I've defined a class named as BT node. As the name suggests, it is going to be a binary tree node. Inside that, I've created two reference variables, left and right. You must remember, in case of binary tree, every node can have maximum of only two children, that is left and right. Hence the reference variable left and right. Then I have created another variable named as data to store the data of a node. Let us begin with the constructor. We have BT node constructor giving the value for these variables: left equal to null, right equal to null, data equal to 0. After that, we are going to have the constructor where we are going to take the value from the user through the variable called as n and pass this to the data. Hence we have left equal to null, right equal to null and data equal to n. That's very good. You have to take the value from the user and pass on to the node data. After this, we are going to set the left node and right node. We write down set left, take the value from the user and give it to the variable called as left. We have left equal to n. In similar pattern, we have another function called as set right, in which we are going to pass the value to the right reference variable through the user variable n. Once this is done, then we have the value to get the functions, that is get left and get right. We are going to return left and right value reference variable respectively to the user. Then we will look at how to arrange for the node values. We have get data and set data. We take the value from the user through the variable called as d and pass this value to the data variable. We have data equal to d and then we are going to return this value. This is how you set a node with its left and right values and data value. Now we will look how to construct the tree. We have another class named as BT. Inside that, I have the reference variable of the BT node, that is root. From this we are going to start the tree. For the default constructor, I have the value root equal to null. After this, we are going to check whether tree is empty or not. So we write down the function is empty and return the value. Is empty is going to be true when root equal to null. Hence, we have the function is empty is going to return the value root equal to null if it is true. If not, then it is going to return the node values. Let us look at how to construct the node. We have insert data. This value is taken from the user, the value of the variable data, and this is passed to the root variable. Root is going to call the function called as insert recursively. We write down root equal to insert root comma data. Then it is going to call the recursive function insert. Let us look at how to code the insert function data. We write down BT node insert with the parameters BT node comma int data. First we will check whether node is null or not. If it is null, it means that there are no values to represent. So let us check with the condition. We have if node equal to null, then node is what? It is going to be new node. For this we are going to write down node equal to new BT node data. This data of the value of the node is displayed to the user. If not, then it moves to the else part. Else, if node dot write is going to be value, we need to check whether it is right is present or not. We write down the function condition if node dot write function equal to null. It means that we are going to insert the data at node. We write down node dot write equal to insert node dot write comma data. If right is not null, then we go for checking for the left. That is your else part. That is node dot left equal to insert node dot left comma data. This is how you insert the values. It is going to be either right or left. If not, then it is going to be exact node. In that case, we are going to return the value as return node. So these are the three set of conditions in which the user needs to check. Now we will move to the another set of function. Let us go. We have the function count the number of nodes. Basically, we are going to return the function count nodes with starting from the root. Now we will look at how to write the code for the count nodes. We have private int count nodes with the reference variable bt node r. If r equal to null, it means the root is null. So there are no nodes to count. In that case, we have the value as 0. So we return the value as return 0. If not, then we are going to count the node one by one. So we move to the else part. Else L equal to 1, that is the value of starting variable. Else we move to the variable L with the value 1. Then we move to the right of the L, count the variables, that is your nodes, and we shift to the next set of side, that is your left and right. So we have the code as int L equal to 1, L plus equal to count nodes r dot get left. In similar pattern we have r dot get right. Once this is done, then the total value of L is represented to the user. Now we look at the main function, that is your searching. This is where you are going to search the value of a value in a given binary search tree. We have the function public boolean search with the value int val. Then we are going to return the value. Return search root comma val. This is going to be called recursively. We have private boolean search with the reference variable r and value. Then we will check with the root value. If the root value has the data, then we are going to return the value. So we are going to start with the root. We write down the condition. If r.getData function is equal to value the user wants to search, in that case we are going to return the true value. If not, it is either going to be present in the left hand side of the root or in the right hand side of the root variable. That is your node. Let us check how we are going to write down the code. We have if r.getLeft not equal to null, then we are going to call the search function. We write down if search r.getLeft comma val. If we found value here, we are going to return true. If not, we are going to write down for the right hand side in the similar pattern. This is how you search for the value in the left and right of the root node, including your root node. Once this is done with the searching, then we go for the traversal of the binary search. First we have in order, in which we are going for the left, then data, and then right, while r, that is a root, is not equal to null. Then we move to the another set of traversal, that is a pre-order. In that case, we are going to first go for the data, then left, and then right. Then we come to the last set of values, that is post order, in which we are going for the left hand side first, then we move to the right hand side, and at the end we display the data of the root node. Let us look at the output of this complete program one by one. First, we are represented with the set of operations the user can perform. Let us begin with the first set of operation. We have insert. We are going to insert any random value. As you can see, I have inserted 20. So in case of this, since it is the first value, we have the post order, in order, and pre-order values 20. Let us look at another set of value. As you can see, in this case, our post order value is 10, 20, and pre-order and in order values are 20, 10. This is how you traverse in a binary search. Now we will look at another set of function. As you can see, we have looked for the value 20 and it is showing me as search element true. That means 20 is present in the given list of array. There are total number of 2 nodes in the given binary tree. Hence the value of nodes comes out to be true. That is 2, 10 and 20. Now we will look at another set of function. This is how you search the value in a given binary search tree. You must remember, today we have learned what doing the binary search tree, how to search the value in the given binary tree, and how to traverse a binary tree. There are basically 3 techniques for the traversal of a binary search tree. These are in order, pre-order, and post order. Also, we look at how to search the value in a given binary search tree. These are very important set of functions which every data structure user has to use while searching a value from a huge set of data. Thanks for watching this video. Please subscribe to Ekeeda channel.